Hello, hello, wherever you are. Guess we'll wait on a few more people to get in here and answer any questions you guys have. Finish my pancakes in the meantime. It's 3 people. You guys got a question, just shoot. Don't be shy. No questions? Yo, what's up, Chris? Sure thing. Okay. Let me see what I come up over here. Let's see. Okay, so can you hear me okay, Chris? Okay, cool. All right, so essentially what's going to happen is this. Do you have a particular one that you know has 2 triangles, or a particular problem you were looking at? If not, I can go get one, but let's see. Maybe I could. Let me go grab one. I'm sorry. I'm just going to pop over to the e-class page real quick. Oh, you got one? Oh, question 1 on the review. Okay. I'm going to pull that up real quick. Give me 1 second. I got the e-class page right here. E-class is running crazy slow, I guess, for obvious reasons. Let me see. Yeah, number 1 on the review. That's right. Okay, so here's what we got. Number 1 on the review. I think we got triangle ABC here, baby Grayson in the background there. So you got triangle ABC. I'm going to show you this in a minute. So we got 19 degrees. We got B is 35. We got C is 32. Okay. So let me pop back over here real quick. All right. This is the scenario they gave you, right? Okay. How's that coming up backwards? It's weird. Anyway. So essentially what we got here is oh, it didn't come up backwards. So yeah, if you look at this real quick, these are the ones you want to watch out for, okay? And I'm telling you right now, I'm going to put something like this on the test tomorrow. But essentially, what you have is this is called an angle side side, okay? Now, if you spelled out angle side side, you'd have a curse word, but that's why we call it a SSA, right? Now, first off, you can use the law of sines here. Here's why. See that 19 and the 32 right there? Essentially, since those match up, we use the law of sines, okay? Now, do you know what we have to solve for here? Chris, I'll put you on the spot since you're the only one out there. Do you know what you have to solve for in this scenario right here? You got it, man. Angle B. That's right. Okay, so we got to solve for angle B. So when we set this up, here's what it looks like. It's we'll say sine of 19 over 32 equals sine of B over 35, right? So this is the thing we have to set up, right? Sine of 19 over 32 equals sine of B over 35, right? And you do your cross multiplication. So you take 35 times the sine of 19, 35 sine 19. You divide that by 32, and that would be sine B. So 35 sine 19 equals 32 sine B, like that. And then you divide both sides by 32, right? Feel free to do this at home with me. And so here's what we get. Sine of B is equal to, let's see, get my calculator out. If I take 35 sine 19 divided by 32, I get like 0.356. Okay, now here's another deal. You see that? See that 0.356? Okay. You're hitting inverse sine. Now, anytime you have to hit inverse sine on the first step, that's the ones where you have 0, 1, or 2. So I'm going to hit inverse sine. It looks like you've already got the answer, right? And it's like 20.86. Is that about right? 20.86. Okay. So about 20 degrees, right? So what I'm going to do is I'm going to say B is approximately 20.86 degrees, right? So check this out. Okay. 20.86. See that? Now, here's the kicker. You remember how inverse sine, it wasn't a rainbow, right? It was the first or fourth quadrants. Anytime I hit inverse sine on the calculator, it has to give me like this. It's got to give me an acute angle, okay? Here's the problem. There's another angle that's between 0 and 180 that has the same sign as 20.86, okay? So here's what you have to ask yourself, okay? This is the only question you have to ask if there's going to be two triangles or not. We just solved for that 20.86, right? Okay. There is, check it out. I'm going to draw you a little picture down here. There is another angle. So 20.86 is right about there, right? There's another angle straight over there that would have the same y value on the unit circle, right? The same sign, okay? The way you find that is this. If you took 180 minus 20.86, you would get 159.14, okay? So here's my point. See how you got 20.86 and 159.14? They're right across from each other. They have the same sign. If you don't believe me, take your calculator real quick. Take the sign of 20.86 and the sign of 159.14. They'll have the same sign, okay? Here's the question you have to ask yourself, okay? Here's the question you have to ask yourself. If I did this, let me get an eraser real quick. I'm going to erase my work here. But if I took the same scenario, right? The same triangle ABC. So think about what we were given at the beginning, right? We were given, sorry. We were given this scenario right here, right? We were given the 35, the 32, and the 19, right? We calculated this to be 20.86, but the other scenario was 159.14. So here's what you need to ask yourself. If I put a 159.14, if I put a 159.14 in there for angle B, would that make sense with the 19 degrees? And here's what I mean by that. If I add 159.14 and 19, right? If I add those together, am I above 180 or below 180? Okay. Well, if you do that, you're going to be below 180. And here's what that means. If you took that 159.14 and added 19, you'd only be at 178.14, which means there would be 1.86 degrees left over. So look, there would be 1.86 degrees left over for that third angle, and that's why you can make a second triangle. Now, over here, that third angle, that angle A is going to be very different, right? So if I took 20.86, right, plus 19, and subtracted that from 180, I get 140.14, right? So 140.14 degrees right there. You see that? So on the answer key, I guarantee you there are two separate answers for angle A. There are two separate answers for angle B, and I'll let you guys do this. But see that side A we don't have? You could set up the law of sines and find that side A and figure out what that is, right? But there would be two separate answers for that, okay? Now, that's a scenario that has two triangles, okay? Now, let's say I put that other angle in there, right? Which is always the supplementary angle to that one, okay? Supplementary angles always have the same sign. Now, if I put that 159 there and I had that 19 sitting there and that ended up being over 180, that means there's no room for a third angle and you would only have one triangle scenario. You would just say, okay, well, forget this one. I'm just going to finish this one up. That'll be my answer, right? Or the last scenario is a zero triangle scenario. And what happens is the first time you go to hit inverse sine, you'll get an error message. And that means, okay, you couldn't even make a triangle with this stuff, okay? But the key is this only happens with the SSA scenario, okay? This only happens with the SSA scenario. And remember, that spells a bad word backwards, so that's the scenario. Okay, so just to clarify, we won't have to figure out the answers to one or both. No, you would have to come up with the answers to both. So this is like number one on the review, right? So if they say, what's the answer for angle B, you would have to say it's 20.86 or 159.14. So that's why I actually drew two separate triangles. Notice the given stuff is still the same, but those others are different. Okay, so yeah, you have to do that. That's correct. So you got to find both. Okay. Can we do a word problem? Trente says. No. Just kidding. We can do that. What's up, guys? You got one in particular you want to see, Trente? Like I worked out those ones. I don't know if you saw it that I handed back and put them online. But if there's one in particular you want to see, or I could make one up. Doesn't matter. Anybody have a word problem they want to see? Oh yeah. There was that one that a lot of people missed. Yeah. Okay. Very cool. And it was a little tricky. So I'll do okay. Number 4. Yeah, the turn 52 degrees. That's right. Give me 1 second, Trini. I'll get to your number 4 because you are going to have to do a word problem on the test tomorrow. So, okay. So let me pull that up real quick. I've got it somewhere. Let's see. Give me 1 moment. God, E-class is dragging. Is it slow for y'all too? It's crazy slow. Yes, course content. Word problem practice number 2. Nolly, you want to say hey to everybody? You say hey everybody, Nolly? Oh goodness, she's not feeling well this morning. Okay, so I got the word problems up right here. Let me make sure you can. Okay, so I'm gonna do the first one where you turn, and then I'll do that number 4. I guess number 4 you're talking about is the one with the baseball field, maybe. If not, let me know. But I'll do this one rewalk 50. Okay, so here you are, right? You walk. This is you. You walk 50 meters in a straight line, right? Okay. So you're going, picture this, you're going this way, right? Okay. Then you turn 52 degrees and start walking. Okay. So what a lot of people did was they just drew like a 52-degree angle right there. That's incorrect. Okay. The reason that's incorrect is if you're walking this way, right? you would have had to turn all this way to have a 52-degree angle right there. You see what I'm saying? That'd be over 90-degree turn. Okay. What you really want to do is this. Okay. Pretend you're walking that way, right? So if I were to keep walking straight, it would be like a line like that. You turned, it doesn't matter which way either. You turn 52 degrees, right? Okay. And then you started going that way. Okay. That angle right there is actually going to be an obtuse angle. Okay. If you took 180 minus 52, that should be 128 degrees right there. Okay. So basically, that would be 128 degrees. And there are only one or two people that got that right out of the crew. I only took half a point off because I knew that was kind of confusing, but that'd be a 128. And then let me see, it says they walked, let's see, they walked 73 more meters, right? So then I walked 73 right here, not 73 degrees, 73 more meters. And they want to know how far was it from here to here? Okay. Look at this scenario right here. Okay. See that? That's called a side angle side scenario, right? Look, side angle side. Okay. Now, you cannot use the law of sines on that because you don't have an angle and a side that match up. So that's right. You got to use the law of cosines, right? And since this is the one you're looking for right here, you're looking for that right there, that x value. It's really easy. Okay. These are the ones we saw for the side. So that side's like by itself. So it'd be like this: x squared equals 50 squared plus 73 squared minus 2 times 50 times 73 times the cosine of 128. And these are fun because you can type all that into your calculator just like that. And then just take the square root of it because it was x squared and you'll have the answer. Okay. So the answer should be online. If you looked it up under the course content, I put it as like word problems practice number 2, work and answers. So you should be able to see that there. But all you got to do is essentially plug that in your calculator right there, and then just take the square root of that, and you'll have it. Okay. But yeah, that if you only turn 52 degrees, that angle right there is not 52 degrees. Okay. So it would help if you kind of like thought about walking and then turning 52 degrees. You know what I mean? You guys actually had her turning 128 degrees. You see, so that was the issue. But I only took a half point off, and I'd say like probably 90% of the people uh, miss that drawing. So you probably missed the problem. Okay, so Trente, real quick, is it the number 4 with the baseball field? Or is it another number 4? So you're saying, Kevin, that she did the 52 in the actual triangle? It's a common mistake. So, teachers make mistakes too, but does that make sense why it's not 52 in the angle if you're walking like that and you turn 52 degrees, right? The 52-degree angle would not be in the triangle. Okay. So just keep that in mind. I don't know if I'm going to do that on a test or not, but just think about that. If I turn 52 degrees, there you go. Okay. So 2 aircrafts. That must have been on the first one then, huh? Let me see. Bear with me. I'm going back to the slow E-class page. Man, 6 periods repping hard in here, huh? Okay. Let's see. Practice problem, word problems practice. Good grief, man. This is taking forever. Sorry, guys. See, we got an aircraft problem here. Great. Now it's not showing me the pictures on this thing. Let's see if I can download this. Forgive me, guys. It's taking forever. Okay, so aircraft problem. Okay. So in order to determine that, so I'm on word problems practice, the first one. And these are the first 8 y'all did. These these were probably a little harder than the other ones, but it says in order to determine the distance between two aircrafts, a tracking station continuously determines the distance to each aircraft and angle between them, determine the distance between the planes, and they got a little picture for you. Okay, so I'm gonna draw this out so you guys can see it if you don't have it pulled up. But basically, you have an airplane here. Let's see, an airplane here. A, B, C. This is 28 degrees. B is 71 kilometers, 71 miles. C is 36 miles. Okay, so look at this real quick. This is what we have, right? And they want to know the distance between these airplanes. So these are my beautiful airplanes here, right here, and right here. They say this is 28 degrees. This is 71 miles, and this is 36 miles. So once again, look, we have what we call a side angle side scenario, okay? I mean, since you don't have like an angle and a side that match up, you guys should see that every side angle side, you have to start off with the law of cosines, and you're going to be solving for this side over here, right? So this is one of the ones that we just had where you have, okay, well, a squared, right, equals 36 squared plus 71 squared minus 2 times 36 times 71 times the cosine of 28 degrees, okay? You would type in, once again, I'm going to type it in real quick. I'm going to type in 36 squared plus 71 squared minus 2 times 36 times 71 times the cosine of 28. And I get this number, 1823. I take the square root of that number, and that should be that 42.7 miles. Okay, so that's where that would be, 42.7. Now, let's just do this real quick. See that 42.7 miles, right? Let's say you want to find these other two angles, right? Can I use the law of sines now? Not all at once. Yes, you can. Yes. Okay. Now, here's a good question for you. Watch this. Let's say I call this A, B, or C, right? Okay. We're missing B and C. Okay. And you're trying to solve this. Which one would you go for personally if you were solving this and you're going for law of sines and you're going to solve for an angle next? Which one would you solve for first, B or C? Angle B. Interesting. Angle B. Interesting. Very interesting. I would go for angle C. Here's why. Angle B is going to be your largest angle. Okay. You could do either one. Now look, hold on. You're going to be better off doing angle C. Here's why. Angle B is going to be your larger angle of the two. Okay. I'm going to be hitting inverse sine. And if it's inverse sine, it'll never give me an obtuse angle, which that could be obtuse. Okay. So let me just show you. Watch this. I know angle C is small because it's got the smallest side. So watch this. If I said sine of 28, right, over 42.7 equals, let's say I went for C. Sine of C over 36, right? I would take 36 sine 28, right? 36 sine 28. 36 sine 28. I would divide that by 42.7. and I get this, I get sine of C equals 0.3958. And I hit inverse sine on that. So if I hit inverse sine of that answer, I get 23.31. So this would be 23.31 degrees. Okay, now if you take 23.31 and you add it to 28, you get 51.31. You subtract that from 180. This angle right here would be 128.69. Okay, 128.69. If you did law of sines to get that, you wouldn't get 128.61. You would get the acute angle, and then you'd be second guessing yourself, like, oh crap, is it going to be the acute one or the obtuse one? You see what I'm saying? So in a situation where you go law of cosines first and then you switch over to law of sines, I would go for the smallest angle first because you know it's going to be acute, and then the rest will just fall into play, right? I promise you, if you went for angle B first, you would have gotten the supplementary angle of that 128.69, because remember, inverse sine can't give you obtuse angles. Okay, see that? See, there's an O right there, right? So you guys that went for B, you might have figured out in the end, like, oh man, this isn't really adding up. But you want to know something cool? Here's a way you could check your answers tomorrow. Okay, any triangle you complete. Okay, y'all help me out with this. My chat just disappeared. Let's see. Oh, there, it's back. Okay, so here's how you can check your answers on this. Okay, everybody get your calculators out. Okay, so let's say 28, right? And it goes with 42.7. So everybody, let's do this. I'm going to take the sine of 28 divided by 42.7. Okay, sine of 28 divided by 42.7. It's like 0.01. Okay, let's do that with the other ones. Okay, 128.69 goes with 71. So I'm going to take sine of 128.69 and I divide that by 71. You notice I get another 0.01. Okay, same thing with this one. If I did sine of 23.31 and divide that by its opposite side, that 36, you get another 0.01. Okay, so by doing that, you've proved that the law of sines is actually true, right? Or you didn't prove it, but you checked your answer with the law of sines. So sine of A over A equals sine of B over B equals sine of C over C. And by doing that, you have that ratio that's constant through the whole thing. Okay, very cool. What else can I help you guys with? It's kind of fun. I'm gonna refresh my coffee real quick while you guys think of that. Number 2 on the same worksheet, the word problem worksheet, the first one y'all did. Let's see. Where did that go? Is that the Pink Panther one? Ooh, yeah. Cool. This is a fun one. So number 2, is that the right one? The Pink Panther one? Where you got that Thanksgiving Day parade float thing? Yeah, Panther. Okay. And then Kevin saying 23 on the review. Okay, I'll remind me in a second. I'll pull up that 23, but I'll do this Pink Panther one real quick. Let me get this drawing down first. Hold on. So I'm not gonna draw the Pink Panther. I'm not. I'll try it. Why not? What the heck? It's 100 feet. This is 49 degrees. And then, nah, I'm not gonna draw it. We need this. Oh gosh, this is fun. Okay. This is what we have essentially, right? And we need that x, right? Okay, so that x right there, okay? This would be a 90-degree angle, right? Right there. Okay. You can't go straight for the x, okay? So here's what you have to do. This is 100. Sorry, that looks weird. That's 100 feet, right? Okay. Does anybody know? Okay, so that's a 30-degree angle, right? Does anybody know what that angle is right there? Hi, height. 150? Not quite. 131. Yes. Because yeah, that's right. It's got to add up to 180, right? So this is 131, right? And if you have a 131 and a 30, that's 161, right? You could figure out up there, if this is 161, how much would be in that left over right there? 161. I can't see the chat. 19. There you go, Megan. All right. So there's 19. Okay. Now, here's what we're going to do. Okay. We're pretty good on this triangle right here. We just got to transfer stuff over here to get over here to get to that. So it's kind of like a two-step problem. So here's what I'm going to do. Okay. Do you see this side right here? If I can find out what that side is right there, I could use that to find x. Okay. So can we use the law of sines here on this other triangle? Can we use the law of sines on this triangle right here? Yes, we can, because we've got that 19 and the 100, right? So since we have the 19 and the 100, we could solve for this side right here. So watch this. I'm going to say sine of 19, right, over 100 equals the sine of 30 over, I'll just call it y, just because I don't want to call it x because I call that x. But this is going to be pretty easy to solve. I'm going to take 100 times the sine of 30, right, and divide that by the sine of 19. So once again, 100 times sine 30 divided by sine 19. So let's see, 100 sine 30 divided by sine 19. And I'm getting y is approximately 153.58. Okay, not degrees, feet. So this is 153.58. I don't know why I keep putting degrees, but there you have it right now. Technically, this triangle is kind of dead to me now. I don't really care about it anymore because I used it for what I needed it for, and now I'm right here, right? See that? Now this is 49, right? This would be 41. And did you know law of sines actually works on right triangles too if you wanted it to? You don't have to. I mean, we could do the other stuff we know, like we could say sine of 49 is opposite over hypotenuse, something like that. But you could use the law of sines here. But law of sines works on any triangle, including right triangles. But let's say you use the law of sines. I don't know. You could say sine of 49, right, over x equals sine of 90 over 153.58. So if you took 153.58, you multiply it times the sine of 49, you get 115.9. So basically, x times the sine of 90 equals 115.91 feet. And do y'all know what the sine of 90 is? Anybody know what the sine of 90 is? Without typing in your calculator? Thank you, Emmanuel. 1. Okay. So if you took 115.91 divided by 1, you would get x is 115.91 feet. So that was like a two triangle thing. You had to go from one triangle, get the information, go to the other triangle. But I'm here to tell you tomorrow's test will not have that on it. You won't have to go two triangles. I'll just give you one triangle, ask you for the missing thing, and then go for it. But there will be a word problem. It'll be very doable. Now, are y'all saying Did I hear 23 on the review? Is that correct, Kevin? 23 on the test review? Can I get a please, Kevin? Do 23 now? Okay. So 23 on the review. Okay, hold on. Do 23 now. My God. Okay. Give me a second. I should have it right here. Please. Okay. Let's see. Where is this thing? Oh, man. Okay. So 1 second. I'm sorry. Course content. I guess everybody's on E-class. That's why it's screwing up. Okay, so law of science, test review. Let's go ahead and download it since I have it. So I have it up. Sorry, guys. It's taking forever. Okay, 23. Okay, so we got, is it the PKH one? Is that right? Okay, let's see. PKH. We got K is 30 degrees. We got angle P is 129 degrees. And then we got H is 4. Okay. So is this it? Okay. I think that's 23. Let me double check real quick. Y'all tell me if that's right. That's a good one? Okay. So law of sines or law of cosines? Tell me, chat, what do you think? Law of sines, law of cosines? You're probably going to want to go sines. Now, I see why you're saying cosines because you're like, oh, I don't have an angle and a sine to match up. But with a little bit of work, you could, because if you took that 129 and 30, you get 159, right? That would leave you 21 more degrees right there. See that? And then you would have it, so law of sines. Okay, so let me erase this real quick. This is called an angle side angle. See, angle side angle, the sides in between the two angles, right? Anytime you have two angles, you can find the third angle right there, and then you just go for it. Okay. So we find that final angle, that's right. And then you can just set up the law of sines from here, and there's no tricks or anything. You just go for it. Okay. So, like, let's say you wanted that side P right there. You would say sine of 21, right, over 4 equals sine of 129 over that angle P, right? Now, this side P, is that going to be bigger or smaller than 4 since it's got a 129-degree angle? Bigger or smaller than 4? Yeah, it's going to be bigger, right? Because bigger angles have bigger sides. So if you start getting stuff that doesn't match up like that, you know you're off. Okay, so that 129 right there, all you got to do is say 4 times. Look, I do this algebra in my head, right? I take 4 times the sine of 129, then just divide it by sine 21. So 4, let's see, 4 sine 129 divided by sine 21. And I'm getting this to be like 8.6 8.67. Is that what the answer key says? 8.67. Okay. And then you could do the same thing with that 30-degree angle, right? That should be bigger than 4, but less than 8.67, right? So you could see that you realize the sine of, look, sine of 21 degrees, right? Over 4, that would still work for this other one. So we just say sine of 30 over k, right? And you take 4 sine 30, divide that by sine 21, and I'm getting like 5.58. So this right here should be your final answer. Okay, so on an angle side angle, just find that third angle first and then just law of sines it straight up. Okay. Make sense, guys, for that one? Oh, it asks for area. Oh, God. Oh, easy. Easy. You want the area? I'm sorry. I didn't even read the directions. I'm just so used to straight up, brother. That's right. I'm just used to finding, solving for it. So you want the area, right? Okay. There are two area formulas, right? There's the Heron's formula. I would never recommend Heron's formula unless you just have three sides. You with me? So going back to this one, angle, side, angle, we would have had to have calculated for one more side because the way that sine formula works, 1/2 AB sine C, you know what I mean? The way that works is this, and this is the cool part about it. I'm gonna erase this stuff. So on this one, I see why you're asking about it now because you needed to find another piece of information before you could find the area. But if you have all this information, here's all you got to do. Pick two sides with an angle in between it, and you can find the area, right? So let's say I took 4 and 8.67, right? 4 and 8.67. What's the angle in between them? Well, it's 30, right? So if you just said area equals 1/2 times 4 times 8.67 times the sine of 30, like that, two sides with an angle in between, you type that in your calculator, you got it. Okay. The same would be true if you took those two sides and took that angle. No difference. Okay. But I'm getting, let's see, 1/2 times 4 times 8.67 times the sine of 30. Oh, cool. It comes out to 8.67 because the sine of 30 is a half. A half of 4 is 2. A half of 2 is 1. 1 times 8.867 is 8.67. Cool. All right. And you should get that any way you did it. So if I did 1/2 this times the sine of that, I should still get like 8.67. Okay. And that'd be square units because we're talking area, right? You know what formulas I'm gonna give you tomorrow? Will we have formulas tomorrow? Yeah, 8.7 is fine. That's right. I'm not giving you any formulas tomorrow. There's only 4 formulas. There's law of sines, law of cosines, area, 1/2 AB sine C, and then the Heron's formula. And you don't even need, if you can find other information, you won't need. I'm a demon. It's Mr. Winslow, Chris. Don't forget Mr. Winslow until you graduate. Okay. But yeah, you got to know the formula. So look, here's all you got to know. How many people got in the chat? 18. Okay, I'm gonna give you a little something here. Okay, so look, you got to know law of sines. Sine of A over A equals sine of B over B equals sine of C over C, right? Oh my God, what a monster. He's making us memorize the law of sines. Do you see how complicated this is? Sine of A over A equals sine of B over B equals sine of C over C. Come on, guys. You got to know that one. Okay. The law of cosines, you got to know the formulas. That's right. So the law of cosines would be just, okay, here's the law of cosines. It's really easy. pick any side you want, right? So you have a squared, right? Then the other two sides are here, b squared plus c squared minus 2bc cosine a, like that, right? Okay, just like that. So that's one version of it. Now you realize this could change, but it's really easy. Whatever's here is also here, right? And the other two just fill in. Okay. Now, um, this isn't a daily exercise. Well, I like hearing your guys' input, but in the end, it's what's best for you guys. All right. So, um, the one thing I will say about this, when you're solving for an angle, don't forget you need to subtract these two over, then divide by this stuff, right? So, make sure if you're ever solving for that angle right there, you subtract the b squared, you subtract the c squared, then you divide by that negative 2bc, and then you take the inverse cosine of uh, whatever it is, okay? And then the other two formulas is like, by the way, like let's say I gave you like an hij, right? For law of cosines, hij. If there's an h here, there's an h here, right? And then the other ones would just be I and j, right? So it's not really a hard formula to do, but I'm just saying if I don't give you A, B's, and C's, don't freak out, okay? Then the other formulas you need would be area equals 1/2 AB sine C. That's an area formula, the one we just did. You just take two sides with an angle in between them. Take those two sides of the angle, 1/2 AB sine C, 1/2 BC sine A, 1/2 whatever sine whatever. You got it, right? And then did y'all work with Heron's formula a little bit? Let's see if I remember. S minus A, S minus B, S minus C. That's Heron's formula right there, okay? The only time you'd want to use that is if they give you three sides only and they say find the area, okay? Now, if you're like, you like that one best, okay? It's pretty straightforward, but if you're like, screw it, I don't want to memorize another formula, you can always just use the information you have to solve for any angle you have, and then you could do 1/2 AB sine C. But it's not that hard to do Heron's formula. Remember, S is called the semi-perimeter. It's all the sides added up divided by 2, and then you just plug that in the formula, and you could find the area very quickly. Okay, just be careful with your parentheses and all that stuff. You know, if you're typing in your calculator, okay? So, 17 people in the chat, huh? All right. I imagine that's about how many people are going online and looking at my crap on a daily basis. 17 from what I'm seeing. But I'm gonna throw you 17 guys a bone right here, okay, in the last 10 minutes. Here's what we're gonna do. I don't know about a bonus, maybe. But I am gonna ask you, if you watch those early videos, I showed you how to come up with the law of sines. How do we come up with it, right? So I want to show you real quick. I'm going to ask you to prove the law of sines to me. Okay. I'm going to ask you to show me how that formula comes about. How do you derive it? Okay. So if you're not clear on that, watch this. Okay. So the reason the law of sines works is as follows. Okay. You got this, right? Triangle ABC. Okay. And you guys hopefully know now that the lowercase letters are the ones across, right? So B, angle B, side B, angle C, side C, and so on and so forth, right? Here's the reason that the law of sines works on any triangle. Okay. Do y'all know what the altitude of a triangle is? What's another word for the altitude of a triangle? The what? The height. Yeah, it's like the height. Okay. So let's say this is sitting right here. could y'all figure out that the height would be like if I brought that down just like that, right? That's the height. Okay. So you 18 people in chat right now. Okay. When I ask you to prove the law of sines tomorrow, first thing you do is draw a triangle ABC. Okay, y'all listen. Draw a triangle ABC and draw an altitude or height, right? Call the height whatever you want. You call it H, call it A. Oh, probably not A if you have A there, but I'll just call it like an X, right? Now watch this, okay? How many triangles did I just form by splitting that down the middle right there? How many triangles do you see inside the big triangle? You see the two right triangles? Yeah. Okay. Very good. Two right triangles. Okay. So here's what we're gonna do. Okay. Very cool, guys. Okay. So here's what we're gonna do. I'm gonna look at this triangle first. Okay. This one, the big one, and I'm gonna talk about this angle A. Okay. Tell me if you agree with this statement. Watch this. The sine of A equals opposite over hypotenuse, right? Do y'all agree with that statement? The sine of A is x over c, right? The sine of A is x over c, opposite over hypotenuse, right? Okay. Now, let's go to the other triangle. This is fun. See that angle? Angle C, right? Chat, type it in for me. What's the sine of angle C on this triangle? What's the sine of angle C? X over A. Very good, guys. Very good. X over A. Okay, now, what I'm going to do is I'm going to solve for X on both those equations, okay? So let's go right here, okay? You know how to solve for X? If you want to solve this for X, you just multiply it by C, right? Okay. So over here, if you just multiply that C over here, you get this. You get X equals C times the sine of A. See that? X equals C times the sine of A. I just multiply that C over, right? Now over here, if you want to solve for X, you know what you do with that A? You multiply it over, right? So if I multiply that A over here, I get X equals A times the sine of C. So what I did was I just wrote two equations, right? The sine of A equals something, the sine of C equals something. Notice they both have X in them, right? So what I did, I solved both for X. Are you guys following me so far? I drew an altitude down the middle, right? I drew a sine formula for this angle, a sine formula for this angle. They both included X in them, or whatever variable you have there, right? Then you solve each one for that. Now, if X equals this and X equals this, guess what? The transitive property of equality says if X equals this and X equals this, then those two have to equal each other, right? So what we get is we get A times the sine of C equals C times the sine of A. C sine A equals A times C, right? A sine C. Now, if you just divide this A over there and divide this C over here, you know what you get? You get sine of C over C equals sine of A over A. And isn't that the law of sines right there? Chris says maybe. That's the law of sines right there, okay? And it would have to work for B as well if you flip that triangle around, okay? You say, what about B? It would also work for it would have to work for any angle you had in the triangle, because if I flip it on another side and do another altitude, it would work for all of them. You see what I'm saying? So that's how we have it, okay? So you write whatever you want to write. But what I'm saying is this. All you have to do is draw any triangle you want. It doesn't have to be ABC, right? Draw an altitude down, okay? Once you draw that altitude down, you can look at those two angles, right? Draw sine formulas for both of them, solve for x, set them equal to each other, and then you can just divide the C and the A or the B or whatever angles you have, and you'll have the law of sine sitting right there, okay? So I'm telling you right now, I'm going to ask you to do that tomorrow. So you 19 people have a leg up on the other people, okay? So saying that, if you want to see this again, this video is gone after we're out of here, okay? So you guys, I hope you got some benefit from it because I meant to post it last night, but E-class screwed up, and I had it like posted last night at 9. That was going to be here at 11. So I apologize if you didn't get the word quick enough, but if you want to see that again, one of the first law of sines videos I did, I proved the law of sines. So you can see that same thing again on that video, and they're all still online. Okay, so make sure you look at that. Okay, so what you want to look over tonight, you want to make sure you've done all the homeworks, right? Make sure you're doing all the homeworks. Y'all saw I put the quiz. I actually put the quiz answers up. I've never done that before, so put the quiz answers up so you can see your version of the quiz. All that good stuff. Okay, we don't have to. No, I'm not going to ask you to prove the law of cosines. It's a little more complicated. So I'm more concerned about the law of sines, to be honest. But it should be doable to do that. Okay, so don't bullcrap me tomorrow either. You know, make sure whatever you have makes sense there. Okay. So make sure you guys look over all your tests, or excuse me, all your quizzes. You got to be doing the homework, because if you're not doing that on a consistent basis and like seeing those answers, it's not going to be good. Okay, so it's basically going to be like completing triangles. Obviously, I'm going to give you some multiple choice questions, so make sure you guys. I made a questions for success thing, you know, so make sure you go look at those on eClass, because it's like those questions I always say ask yourself. They're always up there. Yeah, I'm gonna come in for the test. Yeah, and I'm gonna probably be back. Maybe not the end of this week, but maybe the beginning of next week. I'll be back full time because baby's eating a lot. And he's doing good, so it should be back. So I really do appreciate everybody working with me here. And you know, there are people that are refusing to get on eClass and look at the stuff, and it's not your grade's not going to go away. You know what I mean? So make sure you guys are doing your part. Okay. I miss you guys too, very, very much, for sure. So are there any other like just quick things you guys would like to talk about? I got to go help my wife here in a second, but she was very cool. You know, I said I got it. Taxpayer dollars. I got to be there to help these kids out. Videos are helpful and stuff. Okay, very good. If you watch them, they're helpful. If you don't watch them, some people, those quizzes, oh my gosh, like they had no idea what they're doing. And if you practice law, sines, and cosines, I know there's some tricky stuff, but it's not that bad. You know, like you can figure it out. When you know when to use the laws. So always use law of sines if you have an angle and a side that match up. If you don't have an angle and a side that match up, you have to use the law of cosines. You see? So that's the first thing I ask myself is, you know, when do I use that? Okay, so how do you label a triangle like ASA or SSA? Okay, that's a good question. So always always draw your triangles first, right? Okay. So if you have like a triangle drawn like A, B, C, let's say I did like a 3, a 5, and a 27 degrees right there. That's called a side angle side, because you have an angle between two sides. You see that? That's called a side angle side. And this will be a good way to end this. This is awesome. Okay. So look, side angle side. Are you starting with law of sines or law of cosines? Cosines? Are you sure? Yes, it is cosines. That's very good. Yes. You start with cosines and you have to solve for this first, right? So make a note of that. SAS is law of cosines, okay? Okay, now let's say we did something different, okay? Um, let's say you did, let's say that was 32 degrees and you did a 7 and a 5, right? What do we call that one right there? Like, what is the acronym? Yes, this is an AS. Oh, excuse me. This is a SSA. Yes, very good. That's an SSA, right? Watch your mouths there in the chat, okay? Now is this a law of sines or law of cosines? Close. Is that law of sines or cosines? That's the ambiguous case. That's right, and it's law of sines. Okay, now look, here's what I want you to realize. On this one, you're going to have to you have to solve for this angle right here, right? And you're going to have to hit inverse sine. That's the one where you get 0, 1, or 2 triangles, okay? So make sure you go back and watch those. I went over it again here this morning, but if you missed that, go back and watch those videos on the ambiguous case and how you know, okay? You got to know that, okay? So side angle. Okay, what about, let's see. What if I did, now are you enjoying my lesson? Are you enjoying the lesson? Okay, what if I did this? What if I did? Let's see. We did a side angle side, right? We did a side angle. What if I did a 30, 40, not 30? What do we call that? ASA. That's right. Okay. Can we use the law of sines on that? Is that sines or cosines? It actually, you can use the law of sines. This is a tricky one because you can find out what that third angle is and then you have it. Okay. So on a, what is that, an angle side angle? On an angle side angle, that is going to be a law of sines, right? Okay. So that's an angle side angle. What about a side? What are we going to use? I'm not sure how many questions are on the test. Probably 13-ish. Yes. This is going to be where you want to go for law of cosines, right? Law of cosines. If you want to make your life a lot easier on the law of cosines, with the side, you want to solve for the largest angle first. So which one would be the largest angle here? Which one of these is the largest angle? B, that's right. So go for B first, and then you can convert back to law of sine. So a side is going to be law of cosines. Okay. Now, did you know that there's a possibility that a side won't work? And remember, if you add up two sides, they have to be bigger than the third side, right? So 8's bigger than 4, 9's bigger than 3, 7's bigger than 5. This will work, okay? So you could find that out, but be careful on your algebra on that because remember, you got to subtract those first two over, then divide, then take inverse cosine, okay? So find the biggest one first and then go for that. So what's the other one left? We got side angle side. That's cosines. Side is cosines. Ooh, angle, side, side, angle. Oh, angle, side, okay? So an angle, side would be like a, I don't know, 30, 65, like that. Okay, that's called an angle side, and that's a no-brainer. That's just a law of that's the law of sines. Okay, and what I would suggest on this Okay. So that's 30, 60. That would be a 90-degree angle, right? I would suggest that you find the, oh, no, it doesn't matter here. Never mind. You're just finding sides, so it doesn't matter what you do first. I'm sorry. So angle, angle, side, that would be a law of sines as well. So the only two that are cosines are the side angle side and the side side side. Okay. All right, guys. Well, I hope that helps. Test is tomorrow. So it doesn't matter the location. Okay, so it does. Okay, so real quick, an angle side angle is different from an angle angle side because in an angle side angle you have two angles with the side in between it. Does that make sense? You got two angles with the side in between it. In an angle angle side, the side that you have is not between the two angles. You see what I'm saying? So it does matter the location of the stuff, but you just want to kind of go in order. So like, let me show you one more time. See this? This is an angle side angle. This is an angle angle side. You see how the side is in between the two angles? That matters. Okay. So it's just kind of like a sequential thing. Okay. Same thing with a side angle side. A side angle side has the angle between the two sides. Okay. An angle side side has an angle outside the two sides. Okay. That's the whole thing there. So, yes, it does kind of matter the location. Okay. Does that make sense? Okay. Good. Very good. Okay. All right. So, really enjoyed being with you guys for this hour, 10 minutes. If you run into any other questions and you really can't figure them out, I'll be around. So just shoot me an email. But I hope this helped you guys, and study hard. I'm gonna go take the dog for a walk and help the wife with a little baby Grayson. So I'll see you guys tomorrow, and I will be back full time before long. Okay. No problem, guys. I'm very proud of you guys that are staying up, and I really appreciate everybody's help. So you guys take it easy. I'll talk to y'all soon.